Welcome to the online platform Edu Unlimited. That's Education Unlimited. As we continue our search into math, today we will look at the Pythagorean theorem. The Pythagorean theorem. Again, I ask that you will like, share, and subscribe to this channel as we continue our search into math. According to the Greek mathematician Pythagoras, for all right-angled triangles with hypotenuse as side C, as in this triangle, a squared plus b squared is equal to c squared. Pythagoras made this discovery about the relationships of the side of a right-angled triangle over 2,000 years ago, and today it still holds. Known globally in mathematics spheres as the Pythagorean theorem, interchangeably called the Pythagoras theorem. Let us use the Pythagorean theorem to find the length of side C, the hypotenuse. So let us say that side B has a length of 4 centimeters and side A has a length of 5 centimeters. Using the Pythagorean theorem, we say that c squared is equal to a squared plus b squared. So that c squared is equal to 5 squared plus 4 squared so that c squared would be equal to 5 squared is 25 and 4 squared is 16. So c squared would be equal to 25 plus 16, which is 41. But we want to find c. So we say that c is equal to the square root of 41. The square root of 41 is 6.4. So the length of side C, which is the hypotenuse, using the Pythagorean theorem, is 6.4 centimeters. In this example, we will utilize the Pythagorean theorem to find the vertical height of the triangle. The vertical height of the triangle. The vertical height is this height here. So we label the triangle first of all. This is the right angle. This side is, or this part is angle B. This part is angle A. And this is angle C. So that side C is a common C. In this example, we'll use 10. centimeters. And this side is the side we want to find. We label it X, or the unknown. And this side, 6 centimeters, which is actually side B, 6 centimeters. So using the formula, which is C squared is equal to A squared plus B squared. But we already know that C is 10, so we put in the value of 10. Square the 10 is equal to A is X, the unknown, so we square the X squared plus B is 6, and we, of course, square the 6. So that 10 squared is 100, is equal to X squared plus 6 squared is 36. So we want to find X, so we move the 36 over the equal sign because we want to find X. So that on one side we will have X squared equal to 100 minus 36. So that we want to find X and not X squared, so that this side would read X squared is equal to 100 minus 36 is 64. So we find X as being the square root of 64. Square root of 64 is 8. So X, the vertical height of the triangle, is 8 centimeters. So we utilize the Pythagorean theorem to find the vertical height of the triangle, which in this example, 8 centimeters. So in this example, we will use the Pythagorean theorem to find the height of a building. It's a question that we will imagine that this side here of the hypotenuse is a ladder placed slant on the side of a building. So we will label this triangle. So this is the right angle. This is angle B. This is angle A. This, of course, is angle C. This side, we'll say the hypotenuse is 16 feet, and the length, or the distance rather, between the foot of the building and the foot of the ladder is 7.75 feet. So that the height of the building, which is what we want to find, is X. So that the distance here between the foot of the building at C and the foot of the ladder at A is 7.75 feet. The length of the ladder, which is the hypotenuse, is 16 feet, and the height of the building, which is what we want to find, the height of the building without actually using a measuring device, is x. So we pull the marker to say that c squared is equal to a squared plus b squared, so that c is 16. So we say on this side we'll have 16 squared is equal to a is x, so we'll say is equal to x squared plus b is 7.75, so we'll say 7.75 squared. So that 16 squared is 256. On this side is equal to x squared, and 7.75 squared is 60.0625. So that one side must read x squared is equal to 256 minus 60.0625. So that x squared would be equal to the difference of 256 and 60.0625, which is 195. Point 9375. But we don't want to find x squared, we want to find x. So x would be equal to the square root. Let us put the square root properly. The square root of 195 .9375. So that x would be equal to 13.997776. So that the height of the building without using a measuring device is approximately 13.99. We could also say it is approximately 14 feet. So let us put x is approximately 14 feet. Using the Pythagorean theorem, find the height of a building. So here we find another application example, a wall and a ladder. So that this is the right angle here. This is the hypotenuse. This is angle B, angle C right at the right angle, and angle A, so that this ladder here would be the hypotenuse, the wall would be the vertical height, and the distance between the foot of the wall and the foot of the ladder should be at right angle because they're perpendicular to each other. So that if we were supposed to find the height of this wall, we could measure the ladder on the ground to know that the ladder, for example, would have been, just an example, 16.5 feet. But this part here, let me use a different color. This distance here is actually the 0.5 feet. So in the example, the hypotenuse would be equal to 16 feet. And for example, the distance between the foot of the wall, the distance between the foot of the wall right here and the foot of the ladder is 4 feet. So again, we could use the Pythagorean theorem to find the height of the wall, the height of the wall. My reason for putting this other example is for safety reasons, for one to remember and to note that this is the correct placement of a ladder on a wall. Correct placement where part of the ladder must be taller than the wall or taller than the platform that one is going up on. It is more safe. We will not calculate the height of this wall, but it was placed here to point out, although we utilize Pythagorean theorem, although we utilize maths in our real life, let us do it in a safe way. Again, I hope that you enjoyed this presentation. I ask that you will like and share these videos. I ask that you will subscribe to this channel if you are interested to do well in maths and to learn math. Please, you may also leave a comment in the comment section as we continue our search into this wonderful and appreciative subject called math.